Have you ever had too many apps open, only for your computer to suddenly slow down, freeze, or even crash? It feels like the system just can't handle the pressure, and that's exactly what's happening. Your computer has limited memory, and when it fills up, your computer struggles to figure out what to prioritize and where to store things. But don't worry, your computer has a built-in memory management system that works hard to keep everything running smoothly. Memory management is how your computer keeps track of what's running and where it's stored. Think of it like organizing a workspace. The most important things stay on your desk for quick access. Some items are stored in a drawer for later, and others are kept on a shelf for long-term storage. Everything your computer stores, whether it's a document, app, or game, is saved as binary data, meaning a combination of zeros and ones. These bits are grouped into bytes, and they make up all the digital data you interact with. The job of the memory manager is to organize where these bytes are stored, how they're accessed, and how memory is cleared when it's no longer needed. When you open an app or browse the web, your computer doesn't store all the data in one place. Instead, it organizes data across different types of memory based on how quickly it needs access and how much data needs to be stored. This structure is called the memory hierarchy, and it helps your computer stay fast and efficient. At the very top of the hierarchy are registers, which are the fastest but smallest type of memory. They're located directly inside the CPU and store small bits of data the CPU needs to process immediately. Think of them like sticky notes on your desk that you quickly jot down information on and erase as soon as you're done. Next is cache memory, which sits between the CPU and main memory. Cache is faster than RAM and holds frequently used data, so the CPU doesn't have to repeatedly search for it in slower memory. Imagine you're studying for an exam and you keep the most important notes next to you for quick access. Cache memory works exactly like that, speeding up tasks you perform often, like loading a website you visit regularly or keeping frequently accessed game assets ready. Then we have RAM, random access memory, which acts as your computer's active workspace. It is exactly the RAM that we spoke about in the previous videos. Whenever you open an app, watch a video, or edit a document, that data is temporarily stored in RAM so the CPU can access it quickly. But here's the catch. RAM is volatile, meaning unsaved data is lost if the computer is turned off. RAM is large enough to handle multiple tasks, but if too many programs are running, it can fill up fast, causing slowdowns. On the other hand, ROM, read-only memory, stores instructions that the computer needs permanently, such as the startup program that loads the operating system when you power on your computer. Unlike RAM, ROM is non-volatile, meaning its data is retained even when the power is off. While you don't interact with ROM directly, it plays a crucial role in booting up your system and ensuring essential process runs smoothly. When RAM fills up, your system uses virtual memory as backup. We'll cover virtual memory in more details in a separate video. Finally, at the bottom of the hierarchy, we have secondary memory, which includes hard drives, USB drives, and other long-term storage devices. Secondary memory is where all your files, apps, and media are stored permanently, even when the computer is turned off. Although it's slower compared to RAM and cache, it has a much larger capacity, allowing you to store everything from videos and photos to software and games. In our previous video on process scheduling, we saw how tasks move between different states, but memory management plays a key role in making sure there's enough space for everything. When you open an app, first the system loads the app into RAM, so it's ready to use. Cache memory helps speed up access to storing frequently used data. When you close an app, its memory is cleared and made available for new tasks. Your operating system is constantly juggling memory, allocating, tracking, and freeing it up to prevent slowdowns and crashes. In the next video, we'll be discussing virtual memory, how modern operating system uses memory management techniques like paging and segmentation to make things even more efficient. See you in the next video.